Hello, everyone. This is Adnan, and welcome to Chemistry with Adnan. On this YouTube channel, I'm covering the entire syllabus of IGCSE Cambridge Chemistry, and the course code is 0620. I also offer one-on-one tutoring lessons if you are preparing for October, November intake or like May, June session. So the seats are very limited. And I also own a community on school.com with the name of High School Chemistry. You can join it for free. I offer one lesson per month for free, and there are group lessons which are very economical, around $20 for like 4 lessons a month, once per week. So you can ask questions, you can interact with other students, and yeah, it's an interesting place to be if you are learning chemistry. Okay, so now let's come back to this today's lesson. In this lesson, we are covering 7.1 past paper questions practice. So in our previous video, we learned 7.1, the characteristic properties of acids and bases. So before attempting these questions, or before watching this video, I would suggest you guys to go back and watch 7.1, the characteristic properties of acids and bases. Learn the content for both for core and supplement students for extended, and then come back and try to attempt these questions with me. So that way you will understand it much better. So now, question number 1, it says that state which substance turns yellow when an alkali is added. Okay, so this is about indicators. So what are indicators? Indicators are chemicals which change color when they come in contact with the acidic or basic medium, right? So we have litmus in this list. Litmus is an indicator, and methyl orange is an indicator, and thymolphthalein. So these are the 3 indicators that are included in your syllabus. So this is a memory based question, right? So you must memorize the color change that these indicators will have upon coming in contact with the acid or a base, right, or an alkali. So methyl orange, in its neutral or state, it exists in orange color, and when an alkali is added, right, it changes yellow, right? And when an acid is added, so it changes red. So these are the 2 colors that methyl orange will show upon coming in contact with an alkali or an acid, right? So here our answer is methyl orange. Methyl orange. Yeah. So because litmus, it will have 2 colors, like blue or red, and thymolphthalein, it has also it is either colorless or blue, right? So that is why methyl orange is the answer. I hope this is clear. We move on to the next question. Magnesium is an element in group 2 of the periodic table. Complete the word equation for the reaction of magnesium oxide with hydrochloric acid, right? So in your syllabus, this is the topic where we need to learn that, metal oxide, any metal oxide, when it reacts with an acid, right? Any type of acid. So they will give you salt and water. So any metal oxide reacting with any acid will result in the production of salt and water. Now, this is the equation that you should remember. But now the actual the actual concept is that how do you name the salt, right? So that is also very easy. So you see, hydrochloric acid, they give us chloride salts, right? And if it's nitric acid, HNO3, that's going to give us nitrate salt, right? And if we are using sulfuric acid, right, sulfuric acid with the formula H2SO4, so that is going to give us a sulfate salt, right? So Here, since we have hydrochloric acid and magnesium, so remember the metal from oxide will combine with the non-metal, like except for hydrogen of the acid, right? So it will be magnesium chloride. So magnesium chloride and water, right? So this is a neutralization reaction because magnesium oxide, it has a basic nature. All metal oxides, they are basic in nature, right? They have a pH above 7. So acid and base, when they react together, they produce salt and water. So I hope this is clear. Now the next question is magnesium oxide is insoluble in water. So choose from the list of one other compound that is insoluble in water. So the answer is magnesium carbonate. How do I know this? You need to memorize the solubility rules, right? Let me show you. So these are called the solubility rules, and these are included in your syllabus, which you need to learn in order to figure out that which element is which ions, or like which ionic compounds are will be soluble in water and which will be insoluble in water. So and this understanding is very, very important for this chapter in particular, because there will be lots and lots of questions, especially for extended students, which will check this understanding, which will make sure that whether you understand this or not, right? So here, these are called the solubility rules. You see, now here you can see that let me just make it a bit. So uh, magnesium carbonate, right? So this is carbonate. Yeah. So carbonates, they are you know usually insoluble, right? So yeah, and if group 1 elements are attached with carbonate, or ammonium is attached to a carbonate, then it will make it soluble. But magnesium is not in this list, right? So magnesium carbonate will be insoluble. And now let's take a look at magnesium chloride. All these are soluble. So magnesium chloride. So where is chloride? Yeah, here, right? So yeah, so they are soluble compounds. They're usually soluble, but they can also be insoluble if they are connected with silver, mercury, lead, right? So since they are chlorine, chloride ion is connected with magnesium here and magnesium chloride. So this is soluble, right? So we are looking for something that is insoluble in water. So magnesium chloride is soluble, and that's how we know that it is soluble. Now magnesium nitrate, all nitrates are soluble without any exceptions, right? So this is also soluble. And now magnesium sulfate. So where is sulfate in this list? Yeah, here, right? So it is soluble, but if it is appearing with silver, calcium, strontium, barium, silver, or lead, then it will be insoluble. But magnesium is not in the list, right? So magnesium sulfate will be soluble. So you should practice this. You should memorize this, and there are different ways to memorize this. I have another video about this on my channel where I have explained. I'll link it in the description, that how you should understand and memorize this, these solubility rules. So I hope this is clear. So this is not some kind of magic, that I know that magnesium carbonate is insoluble. It is purely based on this knowledge, right? So now we move on to the next question, which is this question is about sulfur and compounds of sulfur. Complete the word equation for the reaction of dilute sulfuric acid with sodium carbonate. Remember, whenever an acid is reacting with a carbonate, three products will be produced: salt, water, and carbon dioxide, right? So that's why we have three boxes. So sulfuric acid, we know the formula. It is H2SO4, and sodium carbonate, it is Na2CO3. So there, we can also answer these questions. If you don't know the formulas, that's okay, but you should know how to figure the names out of the products, right? So sulfuric acid, that's going to give us a sulfate salt, right, which we discussed in the previous question. And sodium carbonate, so metal will combine with sulfate. So the salt will be sodium sulfate. And now we have these two rows, so I'll write carbon dioxide here, carbon dioxide, and here water, right? So I hope this is clear. Now we move on to the next one. Let me write down the equation as well for extended students so that they can actually like see what is happening here. So Na2CO3, uh, so yeah, that's sodium carbonate, and that is going to produce sodium sulfate and plus carbon dioxide and water, right? So the equation is balanced, yeah, which is very good. All right, yeah, this is the chemical equation, right? And you can see now that sodium, the element from this carbonate, metal from this carbonate, it is combining with the polyatomic ion from the acid, a non-hydrogen part of the acid, and they are going to make sodium sulfate. And yeah, and carbonate is going to lose an oxygen, and it's going to change into carbon dioxide, and that oxygen that it lost will combine with this H2 and they will make water. So I hope this is clear. Now we take a look at the next one. A few drops of thymolphthalate indicator. Okay, that is again a memory-based question. Are added to dilute sulfuric acid. And the question says state the color of the solution. Yeah, so when thymolphthalate indicator, it is colorless, right? And when it comes in contact with acid, it remains colorless. And when it comes in contact with the base or an alkali, it changes blue, right? So now next question, ethanoic acid and magnesium. Okay, this is okay, the question says that complete the word equation for the reaction of ethanoic acid with magnesium. So here, it's a general reaction of acid reacting with a metal. So remember that whenever any acid reacts with metal, you will get salt and hydrogen gas, right? So this is you need to remember. So ethanoic acid, okay. So the problem is the difficult part is that how do you name the salt formed, right? So ethanoic acid, it is an organic acid, which is basically vinegar with the formula CH3COOH. Eth means two carbon atoms. I hope you remember from organic chemistry. So and oic acid means that it is a carboxylic acid. That's the functional group. So and this is a weak acid. So when ethanoic acid dissociates, so it changes into CH3COO negative and H plus. So this ion is called ethanoate. If it is, if you have ethanoic acid, so the ion that will be produced will be ethanoate. So ethanoate, right? And if you start with the methanoic acid, then it will be methanoate. If you start with propanoic acid with three carbon atoms, so the ion will be propanoate, right? So you remember this, concept that how do you change the name of carboxylic acid into its, anion, right? Negatively charged ion. So now how do you write the name? So magnesium will combine with this thing. So metal plus ATE. So metal plus whatever, how many, no matter what, I mean, no matter the number of carbon atoms in the acid, so it will end in ATE, right? Methanoate, ethanoate, propanoate, butanoate, and so on. So the name, how will you write the name? It will be magnesium. The name of the metal, it will remain unchanged, right? So remember that, unchanged. And this will be magnesium, uh, ethanoate. So I hope this is clear. And hydrogen. Okay, now if it is, propanoic acid, and it is reacting with lithium, for example. So the answer will be lithium, right? Propanoate, propanoate, and plus hydrogen gas, right? So I hope this is very clear. And yeah, now we move on to the next question. Choose from the list the pH value that is alkaline. Okay, so 7 is neutral, less than 7 is acidic, right? And greater than 7 is basic. So we have only one value that is greater than 7, so pH 10 is the answer. I hope this is clear. Now, ammonia forms an alkaline solution in water. So give the formula of the ion that is present in all alkaline solutions. Yeah, so alkalinity of a solution is due to the hydroxide ions, OH negative, right? So that is the answer. And or you can, yes, to give the formula of the ion. Yeah, so do not write hydroxide ion. If you wrote hydroxide ion, this will be incorrect because that's not the formula. Hydroxide ion, this will get you 0, even though it is correct. But here they are asking specifically for the formula of the ion. You see, this is where students lose marks. You have to be very, very careful. And that makes me expert on this, right? I train students to write the keywords, the exact keywords to score the highest grade possible, right? And many of my students, they have achieved, they score the highest grade, right? So A star. So now we move on to the next one, which is this question. Okay, I need to change the color back to black. Okay, this question is about compounds of nitrogen. All right, so remember, whenever an ammonium salt, ammonium chloride, that's an ammonium salt, right, reacts with a calcium, a base, that's an alkali, right? So remember that ammonia will be produced, and then a salt will be produced and water will be produced. So remember that this is the general equation: ammonium salt, ammonium salt plus a base, right, or an alkali. So that's going to produce ammonia and a salt, right, and a metal salt, right, a metal salt and water. So now here we need to name the metal salt. So it will be a calcium chloride. This calcium will combine with this, right? So calcium chloride, and the other product is water. So I hope this is clear. Now we move on to the next one. Question number 8. Iron ore contains iron 3 oxide. A blast furnace is used to extract iron from iron 3 oxide. Okay, equations for some of the reactions in the blast furnace are shown. Okay, explain why the reaction in equation 3 can be described as an acid-base reaction. All right, so I told you guys in this question that a metal oxide has a basic nature. You see, I may have written it here somewhere. uh, um, yeah, you see, this is a metal oxide, magnesium oxide. So all metal oxides, they are basic in nature, right? And all non-metal oxides, they are acidic in nature. So that's basically a base, being a metal oxide, and that's a non-metal oxide. Silicon is a non-metal, a metalloid. So this is an acid, right? And it's a neutralization reaction. So the answer will be that calcium oxide, because calcium oxide is a base, and silicon dioxide is an acid, right? And acid base, when they this is that is why it is called an acid base reaction. So I hope this is clear. So you will get 1 mark where when you correctly identify this as a base, and you will get another mark when you correctly identify this, a non-metal oxide, as an acid, right? So this question is about acids, bases, and alkalis. Okay, now, uh, yeah. So now we are moving towards the extended only questions. So the core students will not be assessed on these questions. So now define the term base, right? So for extended syllabus, the definition of a base is that they are proton acceptors. So base is a proton acceptor, right? So remember that, right? So for the core students, the definition is that base is anything that releases OH negative ions in aqueous solution. And yeah, so now state what is meant by the term alkali. Yeah, so it is a soluble base, right? A soluble base. So yeah, bases, they are of two types, soluble and insoluble. So the soluble base, if base is soluble, that is called an alkali, right? So yeah, and if it is insoluble, so the name remains the same, base, right? So base is insoluble in water, and both of them, they have a pH of greater than 7. Okay, so now again a memory based question again. So now they are assessing whether you understand, whether you can correctly identify these compounds from their formulas as acids and bases, right? So metal hydroxides, they are basic, they are alkalis, right? So thymolphthalene, it will change its color to blue, and that's acid. Ethanoic acid, which we talked about a few minutes ago. So whenever thymolphthalene comes in contact with acid, it remains colorless. So again, memory based, you have to memorize these color changes. So the next question is, use the information in table 3.1 to identify the substance with the highest concentration of H plus ions, right? So explain your answer. So use this information in table to identify its concentration of hydroxide ions. Okay, so yeah, so this is there's an inverse relationship between pH and the concentration of the hydrogen ion. So the lower the pH, the higher the hydrogen ion concentration. This is very important to understand. As the pH decreases, the concentration of the hydrogen ion increases, and that makes that substance more acidic, right? And if you are increasing pH, so it means that we are decreasing the hydrogen ion concentration, right? Remember that. So HNO3 has the lowest pH, so that is the answer, right? So substance is HNO3, and the reason is, so because it has the lowest pH, right? Lowest pH, remember that. Okay, now name an indicator which can be used to identify the substance with the highest concentration of hydrogen aqueous ions. Yeah, so that is called universal indicator, right? Universal indicator. So if you don't know about universal indicator, you should go back, watch my previous lessons in the list, in the playlist 7.1, the characteristic properties of acids and bases, and you will, understand that why the answer is universal indicator. I'm not repeating it here. Okay, complete the equation to show the dissociation of ethanoic acid in aqueous solution. Yeah, so you remember that for weak acids, we use a reversible reaction sign, which is this. So you will, draw this arrow, and then you will write CH3, COO negative, right? COO negative, because this is the hydrogen that it dissociates. It breaks apart, and you will write it separately, H plus, right? And that is called what? Yes, that is the ethanoate ion. Okay, so now write the ionic equation, which represents a neutralization reaction between any acid and any alkali. Yeah. So remember that the actual ionic equation, when any acid or base or alkali, they react, So it is the formation of water, right? So H plus OH negative, and that's going to make H2O, right? Let me give you an example here. So for example, sodium hydroxide, an alkali, when it reacts with acid, hydrochloric acid, right? Uh, so they produce so salt and water, NaCl aqueous, and water in a liquid, pure liquid, right? Now, to write the ionic equation, I will split the soluble compounds into their ions. So it will be Na plus OH minus. I break apart, I split sodium hydroxide. I write it like this because it is aqueous. So it will be in the ionic form in the solution in the beaker. And this is also aqueous, so H plus. I split hydrochloric acid as well, so Cl minus. Now, the product that they are forming, the first product, that is sodium chloride, aqueous. So since this is also soluble, so it will be like this in the ionic form. And now the only thing that is not, it is in a pure state in liquid. So we cannot split it, right? So I will write it as it is, because the state symbol liquid, whenever it appears, you cannot split it, right, into ions. Only the aqueous ones can be split. And we can also not split something that has state symbol solid with it, because that will be insoluble. Right, so now we cancel out the species appearing on both sides. So sodium gets cancelled out with sodium, and then chlorine or chloride ion gets cancelled with the chloride ion. So what is left behind is our ionic equation, which represents the neutralization reaction, right? And this is exactly what I wrote. So H plus OH minus, producing water. So I hope now this is 100% clear. If you don't understand this, join my community, which is for free, and I offer once a month, like free lesson once a month, and you can have 4 lessons a month just for 20 bucks, right? So normally tutors, they charge around 40 to 60 pounds for a single lesson, right? So this is very, very economical. Okay, so now next question. A dilute nitric acid reacts with aqueous calcium hydroxide as shown. Okay, blah, blah, blah. Okay, this is a question on titration, which we have covered in stoichiometry in chapter 2 or 3, I believe. So should I solve this here, or should I skip it? Okay, let's solve it here. Uh, okay, so calculate the concentration in grams per dm cube. So whenever you see a question like this, so remember that out of the two reactants, for one, you will be given the volume, both the volume and the concentration. And in this case, it is calcium hydroxide. So the first step will be, you see they are guiding you, right? Yeah, they are guiding you that they are guiding you that calculate the number of moles. So we use the equation C equals to N over V, and we rearrange this equation for calcium hydroxide, because you see volume is given, right, and concentration is also given, right? So you can rearrange this equation to N equals to C times V, and you can find the number of moles. But remember, using this equation, the units of volume, they must be in liters. You must have, or dm cube, right? They are the same. 1 liter equals to 1 dm cube. So you must convert this 20 centimeters into a dm cube. How? By dividing it over 1,000. So when you divide it by 1,000, right? So, and when you multiply, okay, let me write down the whole thing. So when you solve this, you are gonna get, so yeah, so that's 0.02. So 0.02 times 0.015. So times 0.015, you're gonna get 0.0003. So that is answer one. You're gonna get 1 mark. Now when you have the moles of one reactant, then you look at the mole ratio, right, to find the moles of the other reactant. So the standard mole ratio in the balanced equation is 2 to 1. So this is 2 moles, this is 1 mole. But now we have 0.0003 moles of calcium hydroxide. So what will be the amount of this? You cross multiply, right? So you're going to get 0.0003 times 2, and this is going to give you 0.0006, right? So this is how you figure out the moles of the other reactant, right? So now we move on to the next part, and that is calculate the concentration of HNO3. Yeah, very simple. We use the formula C equals to N over V. And remember, and don't forget to convert volume into dm cube. And that's the volume of HNO3 given in the question, right? So that will be, so 25 divided by 1,000, you get 0.025. So 0.025, and the moles that we have are 0.0006. So 0.0006 divided by 0.025, that's going to give you the concentration of this, right? And the concentration of this will be, so 0.0006 divided by 0.025, and that's going to give us 0.024, right? So 0.024 is the answer. Now calculate the concentration of nitric acid in grams per dm cube. So the formula is, so concentration times the molar mass of the compound. So the molar mass of nitric acid is 63, right? So so hydrogen 1 plus nitrogen is 14, the molar mass, and oxygen is 16, but we have 3 oxygens, so 16 times 3. So when you solve this equation, hopefully you will get 63. So it will be 0.024 times 63, and that's going to give you 1.51 grams per dm cube. So I hope this is clear. If any questions, you can leave them in the comment below. Now we move on to the next one. Sodium and lithium, sodium, and potassium are group 1 elements. Okay, so name the type of bonding in these elements. So metallic bonding, these are metals, right? So very easy. This is metallic bonding. So I hope this makes sense. Yeah, since these are metals, so metals, they have metallic bonding, right? So again, a test for hydrogen gas, yeah, squeaky pop, right? So lighted splint. So the test is lighted splint. So when you bring a lighted splint closer to the test tube. So if it's hydrogen gas, you will hear a sound that we call squeaky pop, right? So I will attach a link to the video from another video from another channel. A very talented teacher, graduated from Oxford University, currently teaching, in a British school in the Middle East. So, yeah, so he has demonstrated this, test, right? So, okay, suggest the pH of a solution of a strong alkali. Suggest the pH of a solution of a strong alkali. Yeah, so the strong, anything higher than 7, but a strong alkali will be 14, right? So the higher the pH, the stronger the alkali will be. So and the strongest is 14. We cannot go higher than that, right? So name a substance which can be used to confirm the pH of a solution of a strong alkali. Yeah, so again, universal indicator. Because normal indicators, they only tell you whether something is acidic or basic, right, or neutral. So they do not tell you how strong or how weak a certain acid or an alkali is. So in order to uh, check that, we use universal indicator. And for more details, watch my previous video and then come back, right? And don't forget to like, subscribe, and share. So you can share this channel with your class group. Don't be mean. Try, help other students and succeed together, right? So write the symbol equation for the reaction between sodium and cold water. Okay, so include state symbols. Write the symbol equation for the reaction between sodium and cold water. So sodium is sodium, Na, solid, plus H2O, liquid. And whenever metals they react with water, they produce metal hydroxide and hydrogen gas. So this will be sodium hydroxide and alkali, which is aqueous, and hydrogen gas, which is G, right, a gas. So to balance this equation, we have three hydrogens on the left, and three hydrogens on the left, two on the right. This is not good. So I'm gonna put a 2 here to make it an odd number. So now we have 4, and now I'll have to put 2 here. Now we have two oxygens, four hydrogens, and 2 sodium. The equation is balanced. Ha ha ha. Now we move on to the next one. Blah blah blah. Which one is a neutralization reaction? So B, very simple, right? So H plus OH minus, producing H2O, right? So the first equation, the first reaction, that is a combination, this one, that is ethane plus chlorethane, and that is a substitution reaction. This one is cracking, D, producing an alkene and an alkane. So that is addition. E is addition reaction. F is a single displacement reaction, and G is a decomposition reaction. One reactant, more than one products. Ethanoic acid plus ethanol, ethanoate and water. I don't know. Well, there's both of them. They're acids, and they are changing their functional groups and stuff. So that's an ester and water esterification reaction. Ha ha ha. Yeah, that is an esterification reaction in which esters are produced. So organic chemistry, calcium carbonate, decomposition reaction. One reactant, more than one product, and that is photosynthesis that keeps us alive, right? And yeah, okay. Yes, and and if this reaction GA is written in a reverse manner, so that will be, respiration or combustion reaction. Okay, so I hope this is clear. Now, next one, give the name of the gas that forms an alkaline solution when dissolved in water. So it should be ammonia. Yeah, ammonia has a basic nature, and when it is dissolved in water, so it produces a basic or alkaline solution with the pH higher than 7. So ammonia. Okay. So state what is meant by the term acid. It's the question for extended. So it's proton donor. Do not write anything that releases H plus ions in the aqueous solution. Proton donor. State the meaning of the weak in terms of weak partial dissociation. We have talked about this. Weak acids, they dissociate partially in an aqueous solution, right? CiAT, dissociate, TiON, partial dissociation. Okay, so finally, the last question. Determine the oxidation number of phosphorus in phosphate ion. So from the rules, I have explained this in our previous chapters in chemical reactions or something. So go watch that lecture in order to figure this out, right? So oxygen is -2. We have 4 of them, so that's -8. So they should add up to -3. So X plus -8 equals to -3. So that makes it +5, right? So that is how we figured out the oxidation number of an atom in a polyatomic ion. Okay, so I hope this is clear. And if you have any questions, leave them in a comment below. If you need one-on-one lessons from an expert, which is me, contact me on Google Form, or you can join my community on school.com. Absolutely free to join. You will not be charged. You can get one lesson for free, for absolutely free per month. And if you need group lessons, it's $20, just $20 for 4 lessons a month. Very, very economical, right? And you will be able to interact with me live. You will be able to ask me questions. And yeah, that is it. I'll see you in the next one. Take care. Goodbye.